and all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about color segmentation. A color segmentation is the segmentation. It is based on color features of image pixels, assumes that homogeneous colors in the image corresponds to the separate clusters and hence meaningful objects in the image. In other words, each cluster defines a class of pixels that share similar color properties. Color segmentation is a technique used in computer vision to identify and distinguish different objects or regions in an image based on their colors. Clustering algorithms can automatically group similar colors together without the need to specify the threshold values for each color. Segmentation means it will identify the object of the image. Suppose if you are taking any of the object, suppose I am taking one person, so it is considered as an object. So in this object, how many sub-objects are there? Suppose head, arms, hands. So human visible, how much is there? That is the segmentation. So it is the based on color features of image pixels. Assume that the homogeneous colors in the image corresponds to separate clusters and hence meaningful objects in the image. In other words, each cluster defines a class of pixels that share similar color properties. So a color segmentation is a technique used in computer vision to identify and distinguish different objects or regions in an image based on their colors. Clustering algorithms can automatically group similar colors together without the need to specify their threshold values for each color. So when we are going for the image segmentation, it is one of the image analysis method used to subdivide an image into its regions or objects depending on the type of shapes and objects searched for an image. Image segmentation is an essential first step in most automatic pictorial pattern recognition and scene analysis task. So what are the applications of segmentation? So when we are finding out some objects are there, suppose some multiple colors of the objects are there. So in these objects, some objects are there. So how many objects are there here means it is object 1, object 1, object 2 and object 3. So how many objects are there? How many sub-objects are there? Is the analysis and method used to subdivide an image into regions or objects depending on the type of shapes and objects searched for an image. Image segmentation is an essential first step in most automatic pictorial pattern recognition and scene analysis tasks. So if I am going to the applications, what are the applications of the image segmentation? So inspecting images of electronic boards for missing components or broken connections, detecting faces, facial features and other objects for surveillances, detecting certain cellular objects in biomedical objects. So we are finding out means inspecting the images of electronic boards. So in the electronic boards, there are different types of ICs will be there. So what are the ICs are there? What are the sub ICs are there? So what are the colors are there? How many sub components are there? So in the electronic boards, we have to find out the components and the missing components or broken connections. Total number of components, how much, how many broken and how many missing. So that is the reason. Suppose in my vision, suppose 100 components are there. So number of missing components, number of so total number of present. Suppose present 90 are there. Actually we need 100. So what about the 10? So this 10 may be a broken or maybe a missing. So it will be visible. So inspecting the images, electronic boards for missing components or broken connections. Detecting faces. So we have to find out or identifying the faces, facial features and other objects for surveillances. Detecting certain cellular objects in biomedical images. So when we are going for the segmentation with approaches, how we are approaching for the segmentation. So image segmentation algorithms are based on one of two basic properties of gray level values, discontinuity and similarity. So what are the similarities and what are the discontinuities? So if I'm going for the similarity, another one is a discontinuity. So in the first category, the approach is to partition of the image based on abrupt discontinuity, that is change in gray level, such as edges and image. And the second category is the approaches are based on partitioning an image into regions that are similar according to a set of predefined criteria. So what is the second category? What is the first category? So how we are means based on two properties. That is it is depend on gray level values only. We are taking only gray levels, not the color. So first category, it is an approach to partitioning of the image based on the abrupt discontinuity, that is change in gray level, such as edges in an image. And the second category is the approaches are based on partitioning an image into regions that are similar to according to a set of predefined criteria. So majorly, how many types of segmentations are means? Two types of image segmentation methods are approaching. First one, choosing appropriate filter that help highlight the required features. Another one is a thresholding. So how much is thresholding? So it is a thresholding. So choosing appropriate filters that help highlight the required features. So what is the need of filters means? Reduce the noise, then easy to identify image. So when we are going to the filter, we are reducing the noise. Noise should be reduced. So what is the need of reducing the noise means? It is to easily identifying the image. That is a need of filters. Next one is a thresholding. So in the graphical representation, what is a thresholding? Increasing to decreasing order or decreasing to increasing order. So two types of segmentation methods can be used. And majorly 5 image segmentation techniques are there. First one, edge based segmentation, threshold based segmentation, region based segmentation, cluster based segmentation, watershed based segmentation. So 5 image segmentation techniques, majorly 5 images are there, but two types of segmentation methods can be approached. Majorly 5 are there, but approaching methods are two types. That is the approaching with filters and thresholding. But majorly means edge based segmentation, threshold based segmentation, region based segmentation, cluster based segmentation, and watershed segmentation. These are the 5 image segmentation techniques are there. So another one is a point detection. So it is under segmentation only, but what is the use of point detection? It is a one method of finding out the image with segmentation. So this is concerned with detecting isolated image points in relation to its neighborhood, which is an area of nearly constant gray level. So in the point detection, another one is a simple method. So it is a sub method. This simplest point detection method works in two steps. First one is a filter the image with the mask and we take the absolute values of the filtered image. On the filtered image, apply an appropriate thresholding of the maximum pixels. So already we know that every image we have to take the thresholding and we have to take the appropriate filtering. So filtering is one, thresholding is another method. So here we are taking the filter is a first method and we are applying the thresholding levels. So filtering and thresholding. So it is a concern with detecting isolated image points in relation to its neighborhood, which is an area of nearly constant gray levels. So in this point detection, I am taking a simple method. This simple point detection method works in two steps. So filter image with mask. Mask means when I am taking the -1, -1, -1 like this. So it is the midpoint. So midpoint of the image or center point. So center point of the image. So when I'm taking the midpoint or center point of the image, that is the 8. That means 2 cube. So matrix is 3 by 3. So when I'm taking the 2 cube means 3 is there, no? So 3 means we are taking the 3 by 3 matrix or 3 by 3 pixel size. So -1 means I'm applied the mask here. On the filtered image, apply an appropriate thresholding. Example, the maximum pixel values. So it is one better example to finding out the image segmentation with the point detection. So here I'm taking the input image. So in the image B, the result with threshold level is maximum threshold level. So here the threshold is 220. Here I am taking threshold 220. Here maximum level. Here I am taking result with thresholding of 168. Here thresholding of 118. Here thresholding of 68. Here thresholding of 55. So when I am going for the 55, identifying the image. Okay, so when threshold is 55, then the image is identifying the image. So when I'm maximum level to 220, 220 to 168, 118, 68. When I go into the 55, so then I'm using the threshold level. So when I apply the filter, then identifying. So when we are decreasing the threshold level, then only image is identifying as a segment. These are the eye, nose, lips, like that. So we are identifying the segment as a segment of the image. It is an input image with the resulting of threshold levels are changing. So here increasing to decreasing order. Increasing to decreasing order we discussed. Threshold is a decreasing order I'm taking, then only I'm identifying. So it is the example of point detection using simple method. First one is the original face image. B2D is the result with different thresholdings. So what are the different means? Maximum level 220, 168 level, 118, 68, 55. It is one example I'm taking here to finding out the image segmentation with the help of thresholding values. So in point detection method, the point is detected at a location of x, y. So I'm taking as it is x and y. So the image where the mask is concerned, where the mask is you are applied here. So if I'm taking the mask, then only I'm taking -1, -1, -1, -1, -1. So it is a centered point. So it is to identifying the matrix or image size. So in line detection method, we have two masks so that the corresponding points are more likely to be associated with the line in the direction of the one mask as compared to the another one. Detecting points is fairly simple with the help of standard high pass masks. So when I going to the point detection, when I going to the point detection, one mask is enough. When I am going to the line detection, two masks are required. Two masks are required. So in the line method, we have to two masks are required to corresponding points are more likely to be associated with the line in the direction of the one mask as compared to the another one. So when I'm going for the detecting points is fairly simple with the help of standard high pass mask, where R is the derived from a standard convolution formula and T is the non-negative threshold which is defined by the user. So if image segmentation is a process of dividing of the image into the constituent of the parts of the image, common techniques include edge detection, boundary detection, threshold, region based segmentation. Okay, here I am taking four types are there segmentations. First one is a edge detection, second one is a boundary, third one is a thresholding, fourth one is a region. So when I am going for the edge detection, boundary, thresholding and region based segmentation, these blocks focus on segmenting of our images using color image segmentation through the HSV, hue, saturation and intensity. So it is the HSI, hue, saturation and intensity. So these are focused on these four types are focused on HSI segmentation of the color image segmentation throughout the color space. So another one is a alternative method to finding out the image segmentation. So an alternative approach to the simple method is to locate the point in a window of a given size where the difference between the maximum and the minimum values in the window exceeds a given threshold, and this can be done again in the two steps. First one is about the difference between the maximum value obtained with the order statistics and the minimum value obtaining with the order statistics of the minimum of the value. So maximum and minimum value, the output of the image applying appropriate threshold with the maximum pixel value. Here only I am taking maximum pixel only, but here applying the difference between the maximum value obtained with the order statistic and minimum value obtained with the order statistics in minimum value. So an alternative approach to the simple method is to locate the points in a window of a given size where the difference between the maximum and the minimum values, when I take the maximum and the minimum values of the window exceeds a given thresholding. This can be done again in two steps. So any of the image we have to go for the filtering and thresholding. So when we are going for the thresholding, we have to obtain the difference between the maximum value, order statistic and the minimum value. That is the statistic of minimum filter in the given size mask. But the output image can be applied an appropriate threshold. Example is the maximum pixel value. Here I am taking one example. it is the input image. So it is the maximum thresholding, it is a 90 thresholding, it is a 40 thresholding, it is a 30 thresholding. So which one is the better one means? Here we are identifying. So when the thresholding values are decreasing, when the thresholding values are decreasing, then only we are identifying the image. So input image is converting to the output image with the segments, But example of point detection using alternative method. What is alternative method means? We are decreasing the threshold levels. Here original face image, B2E results of the different threshold levels with the identifying image with the reducing the thresholding levels. We are not taking so much of threshold values. Only just we are taking the around 90, 40, 30 like this. In the previous, we took 440, 220, 110, 80, 56 like that. But here I am taking different levels of thresholding. That is another image, another technique, alternative method of image segmentation. So here there are another type of masks are there. Lower mask, upper mask, saturation mask. So these are nothing but a filters. It is a filtering technique. So after then what we have to do? After then we have to go for the thresholding. So of filter then thresholding. So filters are nothing but a masks. Lower mask, upper mask, saturation mask. In choosing the thresholds, look at the color bar. Example I am taking, segmenting the blue bag. Suppose I am taking the one bag is a blue color. So the lower and upper mask values are appropriate would be 0.6 to 0.7. When I am taking the bag, then the upper and lower mask values are ranging from 0.6 to 0.7. But in the otherwise, it would be only get the blue pixel values of the negligence. Only blue points can be identifying. So remaining means who is responsible means lower and upper masks are identifying the appropriate values of the blue color bag. That is a range of 0.6 to 0.7. But alternate, the saturation threshold is decided. This is a bit tricky because if we need to considering the colors that are seen in the object, so play around with the saturation thresholding that would return the best segmented image. So when I am going for the image segmentation, if I am taking the multiple colors of bags, suppose I have to identify the blue color, then only what is the range means 0.6 to 0.7. Then only it is going for the thresholding. So it is the thresholding value. So how you are identifying means 0.6 to 0.7. So the thresholding values are from 0.6 to 0.7. So it is about the types of masks which are using for helping filtering technique to identifying the thresholding of the image segmentation. Another one is a important one is a line detection. So line detection is a line in a certain direction required detecting adjacent points in the image in the given direction. This can be done using the filters that yields significant response at points aligned in the given direction. For example, I am taking here -1, 2, -1, -1, 2, -1, -1, 2, -1. So when I am taking this one, these are all about the mask and it is about the matrix. So detecting a line. So here I am taking first matrix, second matrix, third matrix and the fourth matrix. But here twos are here middle one, but the twos are here. So it is like this, it is like this, it is like this and it is like this. Okay, it is about the line detection. So like here, so these are the detecting of the light. Highlighting lines in the vertical, horizontal is a 45 degrees direction and -45 degrees in the respectively. This can be done again in two steps. Filter the image using an appropriate filter. Apply an image into the thresholding. Everyone we know that every image we have to take the filtering and thresholding. So line detection is a detecting a line certain direction required to detecting adjacent points in the image in the given direction. This can be done using filters that yields a significant response at points aligned in the given direction. So here I am taking 4 different matrices. This is like this. All -1s are the masked values. Here it is like this. So it is about the line. The lines are vertical, horizontal, -45 to +45 direction I am taking here. So how we are taking means there are 2 steps are there. Filtering the image using the appropriate filter and applying the threshold, that is a maximum value, minimum value to the maximum value. It is one example of line detection. It is the input image. So example of line detection, original image is the input image. B2C, what is happening? Detecting the lines in the vertical, horizontal, that is +45 to -45 direction respectively. So +45 to -45 respectively. So it is rotating. So 45 to like this -45 rotating. That is a line detection. You can observe here. We are identifying here some. It is like an image. I'm not identifying how many white colors, how many black colors like this. But when I go into this image, highlighting the white color. Here highlighting the white. So white is highlighted means line detection is applied. Only white color. So how many white colors are there? Only white colors are identifying from the original image. That is a color segmentation. So when I am going for the line detection, the image processing line detection is an algorithm that takes a collection of an image, edges, point and find the lines of the image in these edges points. Like the most popular line detector are the Hawk transform and convolution based techniques. So edge detection is a process of finding outline of the image. Look like line detection finds the line segmentations, extension of other geometric. Okay, so input image is the original image. We are converting to the lines. Another one is a edge detection. Edge detection in an image aims to extract a meaningful discontinuity in pixel gray level values. Such discontinuities can be detected from first and second derivatives as defined in Laplacian filter. For suppose I am taking first order derivative of an image f of x, y, that is dou f equal to gx and gy. Why I am taking means it is a 2 by 2 matrix. So dou f by dou x and dou f by dou y. It is a magnitude is defined as dou f equal to square root of gx whole square plus gy whole square. But using the absolute values, so dou f equal to gx plus gy modulus I am taking. Second order derivative dou square means second order dou square f of x comma y by dou x square plus dou square f of x comma y by dou y square. So edge detection of the image aims to the extract meaningful discontinuity in an image. Such discontinuities can be detected from the first and second derivatives of the Laplacian filter. So here I am edge detection I'm taking as a 2 types of Laplacian filters. First order derivative, second order derivative. First order derivative of the f of x comma y equal to dou f. Second order derivative I'm taking as a dou square f. Why? Because I'm taking as a image with continuity or discontinuity of the images. So however, Laplacian filter is not used in the edge detection because as a second order derivative, if I am taking the second order means dou square f of x comma y. So it is sensitive to noise. Its magnitude procedure to doubles the edges. It is unable to detect edge direction. So these are the 3 types are there. When I am going for the second order only, it is sensitive to noise. Its magnitude produces double edges. It is unable to detect edge detection. There are first order derivative estimators in which we can specify whether the edge detectors are sensitive to horizontal or vertical edges. Both we study only 2 edge directions, namely Sobel and pivot edges. So when I am taking the image with the horizontal or vertical, when I am taking horizontal or vertical, first order derivative estimates the specifying the edge detection sensitivity to horizontal or vertical edges or both. We study only 2 edge directions, that is the Sobel and pivot edge detectors. So we can discuss Sobel and pivot with the horizontal and vertical. So edge detection is one of the most important tasks in the image processing and scene analysis systems. It denotes the procedure of detecting meaningful discontinuities or edges of the image fixing. So edge detection is the image processing technique for finding out the boundaries of the images and objects within the image. It works by detecting discontinuities of the brightness. Edge detection is used for image segmentation and data extraction in areas such as image processing, computer vision, and machine. Okay, when you're going for the image, this edge detection only I'm talking about the edges. The most important task of the image processing is the scene of analysis system. It denotes the procedure of detecting meaningful discontinuities or edges of the image function. Edge detection is the image processing technique for finding out the boundaries, of the object within the images. It works by detecting discontinuities of the brightness. Edge detection is used for image segmentation and data extraction in areas. Such image processing is a computer vision and machine vision. Edge-based segmentation relies on edges found in an image using various edge detection operations. These edge mark image locations of discontinuity in gray level, color texture, and external. When we move from one region to another, the gray level may be changed. If we can find the discontinuity, we can find the edges. So most probably images are taking as a gray levels to find the thresholding. So edge-based segmentation relies on edges found in an image using various edge detection operations. These edges mark image locations of discontinuity in gray levels, color texture, etc. When we move from one region to another, the gray level may be changed. If we can find the discontinuity, we can find the edges. So these are some examples of step edge, and it is a step ramp size, and it is a continuous ramp or discontinuity ramp or impulse edge or smooth range or ridge edge. So step edge, step ramp, continuity ramp, impulse edge, smooth ramp edge, and ridge edge. So these are the 6 types of edges or color segmentations are there. So Sobel edge detector. This detector uses the following mask to appropriate the digitally the first order derivative gx and gy. So here 000s are there here. When I'm taking the -1, these are the mask values are there. So when I'm taking this one, it is like this. So horizontal and vertical. So Sobel edge detector is for vertical and horizontal. So when I'm going for the vertical or horizontal edge detection is useful. So this detector using the following masks to appropriating the digitally the first order derivative of gx and gy. To detecting, what we have to detect? If the image in the horizontal or edges or vertical edges, then only we have to use this technique. So this horizontal edges, the filter with image f using the left mask above, and the vertical images, we find out the image f using the right mask of the above. But edges in both directions, we can do the following. First one, filter the image f with left mask to obtain the gx, filter the image with f giving the right mask to obtain gy, compare gx square plus gy square or g modulus gx plus gy. In all the cases, we can take absolute values of the filtered image, then apply an appropriate thresholding. So when I'm taking the image, first we have to taking the horizontal and vertical. So filter image f with the left mask of the gx, filter image f with the right mask of the gy. So left means I'm taking the gx, right of the image, right mask is the gy. So both means left plus right equal to gx plus gy. So it take the absolute values in the filter image, then apply an appropriate thresholding. it is one example of thresholding. Suppose here it is the input image. This input image, only white and black colors are there. White and black. But here, when I go into the image B, what are that means? White color is reducing, okay, highlighting the black. We are highlighting the black. When I am going for the image C, what is happening? Dulling the C. So only highlighting. Here, what is means? So we are highlighting the lines. So only the lines we are highlighting. What is the size segmenting? So segmenting the edges or borders with this one. So here example of an Sobel edge detection. First one is a original image with B to D edge detection in vertical, horizontal and both directions respectively. So it is about the Sobel. Next one is a private edge detection. This detector using the following masks to the appropriating GX and GY. So it is also horizontal and vertical. When I am taking the -111 is a mask. These are the matrix values. So the steps of applying this detector as the same that the Sobel detector. Same as Sobel. But what is the highlight means? Private means, we can see here -2 means the matrix is highlighting. So here only I am taking the values are 1 only. So the mask values are there and the horizontal and vertical values are there. Centered values are there. But here and we are finding out the edges of the image. This is detecting the highlighting the masks to appropriating GX and GY. So left considering as a GX, right I am considering as a GY. So GX plus GY with modulus. So total GX plus GY. So it is the input image. It is the figure B, figure C and figure D. What is that means? Original image, edge detecting vertical, horizontal in both directions. But what is the means here? Thresholding values. Comparing with Sobel technique. So it is also like a Sobel, but it is a pivot. But what is the difference means? Horizontal and vertical values I am taking here. But what is that means? Edges of the mask, edges of the images with the masks. -1, -1, -1 I am taking horizontally. Here I am taking vertically. The matrix values is with horizontal values, matrix in with vertical values. That only difference. Remaining all same, but finding out the thresholding values with the Sobel edge detector. So here image segmentations I'm taking as a 2 levels. First level is a applications are there ones inspecting the images of electronic boards to identifying the components, detecting faces, facial and features of the objects and detecting cellular objects in the biomedical images. So segment approaches. What are the approaches means? We are image based on abrupt discontinuity, that is the change in gray level, such as edges. So when I'm taking the image edges, so we are identifying the image edges. Second category is based on partitioning image into regions that are similar according to a set of predefined criteria. So there are majorly 2 methods are there. First one, choosing appropriate filter with the help of highlighting the required features. Another is a thresholding. So first one is a filtering. So filtering and thresholding. But majorly 5 types: edge based segmentation, threshold based segmentation, region based segmentation, cluster based segmentation, watershed segmentation. So first one is a point detection. In the point detection, center point is a size of the matrix or size of the image. So it is a simple method, and it is a one example to changing the threshold value from maximum to minimum values. So it is the, I am taking the image with the horizontal and vertical with the size of x and y. It is a definition of image segmentation to the edge detection, boundary detection, thresholding, and region based segmentation. What are the alternative methods? Means alternative method is nothing but we are changing the thresholding values. So we are taking nearby values 90, 40, 30, 20 like this. So nearby values means we are reducing the levels of the thresholding. So lower mask, upper mask, and saturation mask are the three types of subdividing of the masks to identifying the image or reducing the noises with the filter technique. So line detection is nothing but to finding out the highlighting the lines of the image or borders. So here I am taking horizontal and the vertical values of the mask value and matrix value and images value. It can be done in two steps. Filter of the image using an appropriate filter and applying the image in appropriate thresholding of the image, that is a maximum value. Here one example of it is input of image segmentation of the original image. BCDE are the detecting the lines in vertical horizontal from plus 45 to minus 45 degrees to changing the thresholding levels. And line detection is an algorithm that takes a collection of n edges points and finds all the lines on which these edge points are lies. The most popular line detection are the Hopf transform and the convolution based technique. Edge detection is the process of finding outline of an image, whatever they look like. Line detection finds the line segments. So edge detection is finding out the edges. Okay. So edges are two types, GX and GY. That means so dou f is a first order, dou square f is a second order filter. So it is sensitive to noise and it is magnitude produce double edges. It is unable to detect the edges. So the first order derivative estimates the which we can specify whether the edge detector is sensitive to horizontal or vertical edges of the both. But we study only two edges of the detector in Sobel and Privet edge detector. Only in the horizontal or vertical in the size of the image, especially we are using Sobel and Privet of the edge detection segmentations. So edge detection is one of the most important tasks of the image processing, and it denotes the procedure of detecting or meaningful discontinuities of the image function. So edge detection is an image processing technique for finding out the boundaries of the image within the image, and it works of the detecting discontinuities of the brightness. Edge detection is used for image segmentation, the data extraction of the image in the computer vision and machine vision. Image segmentation relies on edges found in an image using various edge detection operations. These edge marks are image locations of discontinuity in gray level, color, and texture, etc. When we move from one region to another, the gray level may be changed. The discontinuity of the images can be found. It is the types of images: step edge, step ramp, continuous, impulse, smooth ramp, and ridge ramp. These are the edge detections in the color segmentation. So it is a Sobel edge detecting. How we are means we are finding out with the horizontal and vertical matrix. So mask values and matrix values and the image pixel values are taken in a horizontal and vertically. It is one example of Sobel technique to finding out or to highlighting the edges or lines of the image. Privet edge detector, it is same as Sobel, but what are the changes means we are changing the levels of the thresholding. It is one example of the edge detection of the privet edge detector. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.